This lab is going to be a little bit different than some. This lab is mainly about using the oscilloscope. So your objectives are to gain familiar with the oscilloscope, which I just said, measure DC and AC voltages in the period of an AC signal, and then create a calibration curve for a signal generator, which we'll provide you, and it'll make Lissajous patterns, which are pretty neat. Basics, this part looks just like a cathode ray tube, and that's all it is. So, cathode ray tube. Then, you'll notice that there are these little grids. The blocks right here, like from here to here, this is called a division. The x-axis is the time of a signal, and then the y-axis up and down is your voltage. So if you have a time varying thing, and if you set your time per division, side note, general note on using an oscilloscope, every knob is labeled. In this lab, you are going to be flipping all of the knobs. You get to experiment a little. So those of you who like to push all of the buttons, push all the buttons. The only thing not to do is that red button right there. Make sure that this knob, red, is fully, and let's make that look like an F, clockwise. That is a calibration knob, and you don't want this to be uncalibrated, so turn that all the way to the right. The big black knob on the bottom, you're going to play with that, but don't move the red knobs unless it's to move them fully clockwise. So as you adjust the voltage knob, these volts per division knobs, you'll change your up-down, and your time is your left-right, time per division. So you'll get to play with it and see what the signal looks like. Other notes, these knobs that say position and they have little arrows, well, play with them, figure out what they do. This is a 2-channel oscilloscope, meaning you've got this channel over here, channel 1, this is signal 1, this is channel 2, signal 2. This vertical toggle says, what are you looking at? Well, I'm either looking at an AC signal, a ground signal, or a DC signal. We'll talk about those in a minute. And this mode button tells you what you're looking at. So right now this is set to channel 1. You're looking at channel 1. Okay, so rundown. Change time scale, change voltage scale, move things. Alright? And then what am I looking at? Good. You'll get to hit all the buttons. They're fun. So data collection. Data collection, as we just said, you have time, voltage. Now you'll notice there's no scale written on here. That's because it changes. You'll get it from your knob. So let's say you have a signal that is this square wave right here. Well, we would say that this signal is, well, it is 1, 2, 3, wait, 1, 2, 3 tall. So I'm going to say 3. And, oh, if I look very closely, you can use these little hash marks. So use those to get real close. They are in 0.2 increments. I can't really tell. I'm going to go ahead and say that that's 3.1. It's halfway between hash marks. Why not? So that's 3.1 divisions times, oh wait, I'm on channel 1. I can tell because that knob is set to channel 1. And this is set to 0.5 volts per division. So let's say 0.5 volts per division, meaning the signal is 15.5 volts. All right, so whenever you are measuring something, you will always get number of divisions, times whatever the knob reads. For DC voltage readings, the first thing you need to do is set, what's 0 going to be? So that's where you use this ground. This gives you your 0 point. And it'll do something neat over here. I don't want to give too much away because I want you to play with it and discover, and, well, I don't want to rob you of pushing all the buttons. So this sets your 0. If your 0 is off the screen, maybe there's a knob that would let you move it around. The best place to do is to set your 0 to the bottom line. So set 0 position to the bottom line. That way it's very easy to move up and down. Sorry about that. One thing that you also know is you want big jumps. Alright? So if you see that it only moves a little bit, then I want you to find the knob on here that will make it jump a lot. And you're going to alternate between the ground and then the DC button. So you'll be ground, that'll be 0. DC will measure your DC voltage. And you'll watch what happens. So you want to get the biggest change so you have the most accuracy. And accuracy being because you can read more divisions. So the next thing you're going to do is you're going to measure AC voltages. And to measure your AC voltages, you're going to use what's called a trainer. Now, all this means is that there are a whole bunch of features here that let you test circuits. PC board, which you're familiar with, but the part we are looking at is this AC circuit generating piece right here. You're going to plug one into here, one on the positive 15, so one in channel 1, and then one in channel 2, which is your ground. And this will make an alternating current signal between plus 15 and ground being 0. Right? Other key point not to note, do not touch these wires. They are here. Do not move them. Thank you very much. Just don't move them. So your AC signal is going to make something that looks like okay, it won't sound exactly like that, but it can in your head. You can make whatever sound effect you want. So it'll go up and down. And the voltage you read, you saw on the trainer, it said 15. Well, 15 volts is VRMS, which is the root mean squared. So to actually get this, VRMS is 1 over 2 root 2 V peak to peak. What this means is RMS is kind of an average. It's the root mean squared. Because your signal goes up and down, if you average this, you'll get 0. And that's not what you want. That's not very interesting. Because there is definitely voltage going through here. RMS is the root of the average of the squares, the root mean squared value. And if you square a sine curve, your average is out to about 1/2. But since you squared it, that's where you get this square root of 2, right here. So your peak-to-peak voltage is not going to be 15. It would be 15 times 2 root 2. Again, make sure that you've got this set on the AC setting and measure your divisions. This is going to be a little bit tricky, so we're going to go over how to read half your curve, shift it, and then read the other half in a little bit, but we'll talk about that in lab. Error analysis, you have divisions, which you read from your screen. You get volts per division, which you read from the dial. And then you get your answer. So, some number right over here. Now let's say you have plus or minus, let's say it's 0.1 divisions, because you only trust yourself to reading halfway between those divisions, which I think you can do better, but let's say you only do. So 0.1 divisions, let's say you have 3 volts per division. Then your uncertainty goes to plus or minus 0.3 volts. And we get that just by multiplying these two together. So 3 divisions times 0.1 divisions plus or minus 0.3. Not too bad. Not too bad at all. Then you're going to make Lissajous patterns. So we know this time signal that comes out of the wall. You're going to measure that. Again, time goes on the right axis. And the power company does a really good job of getting it a frequency of 1 over 60 seconds. This is the frequency of the wall. Very well tested. So you're going to use a signal generator, and every time you get a multiple of 60 hertz on your function generator, you get something neat. I don't want to take away what it is, but it looks really cool. But it's not exactly going to line up. Because your function generator, your signal generator, is not calibrated. So if we look at this, we care about the offset. So let's say at 60, you actually measure 54. Well, 54 is 6 below, so this would be, let's say this is minus 3, this is minus 6. And that would be a point right here. Let's say at 120, you measure 121. Okay, well that's plus 1, so let's put that right here. And then at 180, let's say you measure 170. Oh, that's minus 10, that's way down there. And your calibration curve is just going to look like a whole bunch of weird dots. Don't connect dots. Because what happens at 60 hertz doesn't affect what happens at 120. You're just saying that at these values, at 60, 120, 180, and 240, I am off by this much. You do not connect your dots. Now, the lab says to go to 420. I have seen students get in the low thousands. It's not a bad way to spend a day. It's pretty fun. So the wrap up, you get your measurement and uncertainties on all voltages and times, because you're going to get the time of the AC signal. DC won't have time because it doesn't change, but the AC will. And then you're going to build me this calibration curve. Again, more of an exploratory lab, but that's kind of the fun. Now you get to use a really fun piece of equipment, and we'll be using it from week to week, so learning it, not a bad idea. Not a bad thing to do. Well, I hope this helps. I will see you in lab.